Now, in terms of solving for the volume and surface area of spheres and hemispheres, the formula for the volume of a sphere is 4/3 pi radius cubed. For a hemisphere, in order for you to figure out the volume, it's basically taking the volume of the sphere and taking half of it. So it's half 4/3 pi radius cubed, and then of course 1/2 times 4/3 is 4/6, which can be reduced to 2/3 pi radius cubed. So this is the formula to figure out the volume of a hemisphere and the volume of a sphere. In terms of surface area, however, surface area is different. Think of surface area as wrapping paper. You basically want to wrap all around the ball, okay? Either with wrapping paper, with aluminum foil. You're going to cover all of it around the sphere. Same thing for the hemisphere. When we're talking about actually going ahead and finding the surface area of a hemisphere, I'm going to take the surface area of a sphere and I'm going to cut it in half. The only difference is that you have to pay attention to the problem. The surface area of a sphere is 4 pi radius squared. The surface area of a hemisphere is 1/2 of 4 pi radius squared. But when you cut this in half, you need to then add the bottom circle. You're like, where is this coming from? Let's go ahead and picture an orange. So let's say that on my screen, I have an orange, okay? Like the one that you eat. We're now going to cut this orange in half. And let's pretend that we have covered this orange all the way around with aluminum foil. Okay, so the orange is completely covered with aluminum foil. We're going to cut the orange in half, or the tomato, or whatever it is that we're talking about. So the orange is going to be cut in half. It's still going to be covered with aluminum foil. But think about the inside. The inside of that orange is now going to be exposed. It's going to be exposed because you had everything covered on the outside, but not in the inside. Therefore, what's going to happen is that in order for you to find total surface area, not only is it taking half the surface area of a sphere, but now you're going to have to cover that exposed circle, which is the cross section when you cut it in half. So that is where the additional pi radius squared comes from. So in reality, this is going to equal 2 pi radius squared plus 1 pi radius squared, which is just simply 3 pi radius squared. So the surface area, the total surface area, okay, so that means the rounded part plus the circle, which would be flat now, that is now going to equal 3 pi r squared. So this right here would be the circle in the bottom. That is the additional circle that we would be adding. So now in this third and final video, it says Loretta has molded a sphere of radius 12 centimeters out of clay. Later, she remolds 4 smaller spheres out of the original bigger sphere. Work out the volume of the original sphere and the total surface area of the original sphere. So there's multiple parts to this question. Let's go ahead and just work first with part A. Part A says to work out the volume of the original sphere. The original sphere has a radius of 12. What's easy about spheres is that in reality, all you need is the radius in order for you to get these answers. So for part A, the volume formula for a sphere is 4/3 pi radius cubed, because here we know that the radius is going to be 12. We're going to be able to put this all into the calculator. 4/3 times pi times 12 cubed is 7,238.229474. So that's going to be approximately 7,238 cubic centimeters if I were to round to the nearest whole number. Then it says to figure out, of course, the total surface area. Total surface area, which is going to be 4 pi radius squared. So this is 4 pi. The radius of the original sphere is 12. Put it all in your calculator. So this total is 1,809.557368. So this is approximately 1,810 square centimeters. Remember, the units for volume is always cubic units, but then for area and surface area, it's always square units. So we figured out the volume of the original sphere. The volume, like I said, is 7,238 cubic centimeters, and the surface area of the original sphere is 1,810 square centimeters. All right, so we just found the volume of the bigger sphere, and if we want to find the volume of each of the smaller spheres, I'm going to have to go ahead and find the volume and divide it by 4. So for part B, let's go ahead and divide 7,238 by 4, since she's remolding it into 4 smaller spheres. If you can, grab the answer that you still have in the calculator for the 7,238.229474, divide that by 4. And we do that because we want to basically avoid having round off error. When we divide by 4, we end up with 1809.557, which is coincidentally the same exact answer as the surface area of the entire thing. So the volume of each of those smaller spheres is 1810 cubic centimeters. In part C, it says to calculate the radius of the smaller sphere. We found out that one of the smaller spheres is going to have a volume of 1,809.557. So we're going to set up the problem by substituting into the volume formula of a sphere, which is 4/3 pi radius cubed. We're going to substitute 1,809.557 is equal to 4/3 pi radius cubed. In this case, we're looking for the radius because that's the part that we don't know. Let's go ahead and divide both sides by 4/3, which is the same as multiplying by the reciprocal 3/4. So either take 1809.557, which you should still have in the calculator, all of those decimal values, and either divide that by 4/3 or multiply by the reciprocal 3/4. So you're going to get 1,357.16775 is equal to pi radius cubed. Let's go ahead and divide both sides by pi. So you get 431.999912 is equal to r cubed. You want to now take the cube root of that number, of that 431.999912 is equal to r. If you're using a graphing calculator, when you go to math, which is a button on the top left side of your calculator underneath the green alpha button, you will see that you will be able to find the cube root. It is choice number 4. So then you can choose the cube root of the answer, which is 431.99, and you're going to get an answer of 7.56 if you round to 3 significant figures. So that means that the radius is approximately 7.56 centimeters. This means that the radius of one of the smaller spheres is going to be approximately 7.56 centimeters. So that's going to be the answer to part C. And from here we can answer part D, which asks, would the total surface area of the 4 smaller spheres be the same as the surface area of the original sphere? Justify your answer. So think about that for a second. Do you think that the total surface area of 4 smaller spheres is going to be the same as the surface area of one original sphere? So you have to think in terms of wrapping paper. Imagine you're wrapping a ball, but then from that same ball, you're going to make 4 smaller ones. Will you be using the same amount of wrapping paper to do that? So that's what we're trying to investigate right here. And in order for us to figure that out, let's go ahead and find the surface area of one of the smaller spheres and then multiply that by 4 to find the total surface area of the 4 smaller spheres. So let's go for it. So for one small sphere, surface area is 4 pi radius squared. We just found in part C that the radius is 7.56. So let's go ahead and put that into our calculator. 4 times pi times 7.56 squared, and that's going to give us about 718.21 as our answer. So this would be the surface area basically of one of these smaller spheres. I'm going to now multiply that answer by 4 so that I can go ahead and figure out what would be the total surface area of all 4 of these spheres, of the smaller ones. So when I multiply, I'm going to get approximately 2,872. I got 72.85. Depending on whether you're using the entire amount for the radius in your calculator, then your answer might be a little bit off, but either way, it's about 2,873, 2,872 square centimeters. How does that compare to our original answer? Let's go back to the problem. In the original question, for part A, notice they asked us to find the surface area of one of those original spheres. And now when we find the surface area of the 4 smaller ones, this is going to be square centimeters, it is clear that these two are not equal to each other. The surface area of the 4 smaller spheres is greater than the surface area of the original sphere. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.